solve this equation carefully. We are given that x cubed plus x squared equals 810, and our goal is to find all possible values of x. The first thing we're going to do is rewrite 810 in a more useful form. Notice that 810 can be written as 81 multiplied by 10. Now, 81 is simply 9 squared, so we have 9 squared multiplied by 10. Next, observe that 10 can be written as 9 plus 1. The reason we do this is because it allows us to distribute 9 squared across the sum. So 9 squared multiplied by the quantity, 9 plus 1, becomes 9 cubed plus 9 squared. This means we can replace 810 with 9 cubed plus 9 squared. Our equation now becomes x cubed plus x squared equals 9 cubed plus 9 squared. Now let's move everything to one side so that the equation equals 0. Subtract 9 cubed and 9 squared from both sides, giving us x cubed plus x squared minus 9 cubed. Minus 9 squared equals 0. Let's group similar expressions together. We can write this as the quantity x cubed minus 9 cubed plus the quantity x squared minus 9 squared equals 0. At this point, we're ready to use two well-known algebraic identities. The first identity is a cubed minus b cubed equals the quantity a minus b multiplied by the quantity a squared plus ab plus b squared. The second identity is a squared minus b squared equals the quantity a minus b multiplied by the quantity a plus b. Here, a is x and b is 9. Applying the first identity, x cubed minus 9 cubed becomes the quantity x minus 9 multiplied by the quantity x squared plus 9, x plus 81. Applying the second identity, x squared minus 9 squared becomes the quantity x minus 9 multiplied by the quantity x plus 9. Notice something important here. Both terms contain the common factor, x minus 9. Whenever every term has a common factor, we factor it out. Doing that gives us a quantity x minus 9 multiplied by the quantity x squared plus 9, x plus 81 plus x plus 9 equals 0. Now let's simplify the expression inside the brackets. 9 x plus x gives us 10x, and 81 plus 9 gives us 90. So we obtain the quantity x minus 9 multiplied by the quantity x squared plus 10, x plus 90 equals 0. Now, apply the zero product property. This property tells us that if the product of two expressions is 0, then at least one of the factors must be 0. First, let x minus 9 equal 0. Solving this immediately gives us x equals 9. That is our first solution. Now let's solve the second factor, which is x squared plus 10, x plus 90 equals 0. To determine the nature of its roots, we'll calculate the discriminant. Remember that the discriminant is b squared minus 4ac. Here, a equals 1, b equals 10, and c equals 90. Substituting these values, we get 10 squared minus 4 multiplied by 1 multiplied by 90. 10 squared is 100, and 4 multiplied by 90 is 360. Therefore, the discriminant is 100 minus 360, which equals negative 260. Since the discriminant is less than 0, this quadratic has no real roots. Instead, it has two complex roots. Now let's use the quadratic formula. The quadratic formula says x equals negative b plus or minus the square root of b squared minus 4, ac, all divided by 2a. Substituting our values gives x equals negative 10 plus or minus the square root of negative 260, divided by 2. Now, let's simplify the square root. Negative 260 can be written as negative 1 multiplied by 4 multiplied by 65. The square root of negative 1 is represented by the imaginary unit I, and the square root of 4 is 2. Therefore, the square root of negative 260 becomes 2I times the square root of 65. Substituting this back into the formula gives x equals negative 10 plus or minus 2I square root of 65 divided by 2. Finally, divide every term in the numerator by 2. Negative 10 divided by 2 is negative 5, and 2 divided by 2 is 1. So the remaining two solutions are negative 5 plus I times the square root of 65 and negative 5 minus I times the square root of 65. Therefore, the complete set of solutions is x equals 9, x equals negative 5 plus I, square root of 65, and x equals negative 5 minus I square root of 65. If this step-by-step explanation helped you understand the algebra and factorization more clearly, don't forget to like the video, subscribe to the channel for more mathematics lessons, and leave a comment letting me know which problem you'd like to solve next.